Okay, so today there will be two parts for the lecture. In the first part, about 15 minutes, I would like to just talk more about selections. You're going to use selections for your lab number 2 and also for all the future labs. So I want to show you more examples and talk a little bit more about more logical ideas, which is really what you're here to learn. And the second part, I will start talking about classes and objects. So we learned something already from the tutorial series, but it's only for you to get started, to get some experience. But now I would like to also do some formal introduction to it, but we'll still talk about throughout the course about classes and objects. It's a very big topic. I would like you to have some very solid background before you graduate from this course. Otherwise, when you get to 2030, you'll be having a hard time. Okay, that's what I hope you wouldn't have. Okay. Let's now, first of all, go back to selections over here. Okay, let me just adjust my slides very quickly, and then we'll start from the beginning. Okay, so let's first of all talk about the motivation for selections. Okay. Sorry, give me just one moment. Let's first of all see why we need selections. So there's classes and objects. Selections over here. And then also show you some Intro Studio stuff. Okay. Okay, selections. Okay, let's go there. Okay, selections. So basically, we're going to talk about, remember in the elementary programming lecture, we talk about types such as integer, integer, character, string, and also double. What we like to add to the collection of data type is something called Boolean. And the Boolean itself is very easy, just true or false. However, the way you manipulate the values for Boolean is rather complicated. That's why we got to learn about logical operators. So that's something we'll learn. But before we do that, let's learn a little bit more basics about if statements. And then we're going to talk about, so the topic about compound versus primitive statements is a fancy term for saying either simple or complicated. So I'll show you some complicated case in just a moment. And also I'll show you some common errors and pitfalls for writing selections code and also logical operations. We'll only get to some of this, so we still have to continue for next week. Okay? So let's now see a very some example which we went through last time. I will show you give you a quick review of what we did, and then let's try to see some illustration quickly in Visual Studio. Remember last time we talked about you can use scanner to actually read the input from the user. Okay, you can read a string, you can read an integer, you can read a double. So now let's say we declare scanner over here in line number 4, and then we try to say now let's declare a constant double, which is 3.14 for the pi. And then we say that we prompt to the user, give them some instruction to say, now enter the radius of a circle. And then the user is we're going to say input our next double. That's something we showed you last time. So that means the user is going to type something on the keyboard. And this corresponds to when the user types something on their mobile screen, the same thing. Okay, so the radius for the user is going to be some user input. It can be 3, it can be 4, it can be 5, it can be 5.23, any number. And then we're going to calculate the area accordingly. Okay, we're going to say radius times pi. And then we're going to tell the user this is the area of the circle of this kind of radius. Okay, so now I'm going to run this with some input just to show you an idea. And then I want you to think about what can be wrong for this program. Think about it. Okay, let's go to Visual Studio over here. Now you will see that I will post the source code for you to play with after the class. Okay, so let's say I have the class over here. Let me just select that. It's called Circle Calculator. Let me just make it a little bit bigger for you to see. Okay, and also I'm going to have the console ready to show you. Okay, so this is exactly the code I just showed you on the slides. I just type it out. So now I want to run it and show you a simple run, okay, to get an idea. So now let's run it. Okay, I'm going to say run. Okay, let's wait for the Gradle to build. Okay, it says that enter the radius of a circle. To make it simple, what about just 3? I can expect a program to go 3 times 3 times 3 times 3.14. Okay, it will tell me that this has the area of this number. Okay, it's actually correct. Okay, Now, you can see that the way we actually run this program is, whatever the user actually enters from here in line number 7, we simply take it and then calculate the area. Is there anything wrong, logically speaking? Can we always assume the user is going to enter something that makes sense? Apparently we cannot, right? Let me illustrate to you. That's why we need selections. Okay, why don't we try very quickly? Now let's run the same program over here. Let's see how ridiculous the program can get into, because we were not careful enough. So now, what about -3 for the radius? Because the original program there doesn't really check to see how large or how small the input is. In the case it is negative, it will still calculate using -3. In this case, it tells you circle with radius -3.0 has the same area, which does not make sense. So what do we really expect to see an ideal program, which I will show you? What we really expect to see is, if you enter a radius that's not larger than or equal to 0, you should really give some error to some point, right? That's something you should display on your mobile screen, for example, to say, oh, no, if you have a radius for circle, it's got to be non-negative, okay? But this program is not doing it. So that means we want to have some selective action to say, only under certain circumstances are we going to calculate this area, okay? That's kind of just one example to show you, okay? Any question about this simple illustration here? That's just one scenario where you need selections, but there are many, many other scenarios you need selections. Every time when you want to say, up to this point of the program, I might do something, action number 1, if something is true. I might do action number 2 if something else is true. Or in general, it can be many, many conditions there that might be true. Okay, so this is just, you can see that if we enter -3, it's also going to calculate, so that's a problem. Okay, it's just illustrated. Somehow you want to distinguish between valid and invalid input values. We'll see how we can improve this particular program in a moment. I'll show you. Okay, this is just another example. Let's say if you enter a number, you want to say depending on how large the number is, you want to say it's either 0, positive, or negative. Of course, you cannot just have a single sequence of programs, a sequence of statements to actually achieve this. You need some selective actions. Okay. Similarly, you can see depending on it's either positive or negative, your output could be different. Either you can see positive over here or negative. Okay, that's just another example. Okay. Okay, so now, what we really want to do is to have some branching conditions over here to say if we can either go to this branch or that branch or another branch. Okay, I'll leave you to read the slides. It's rather simple. I just want to go to examples directly. Okay, now before I talk about our if statements, which we informally introduced last time, let's talk about a new data type. So remember what a data type is. A data type is simply a collection of relevant values. When we talk about integer data type, it's all the integers starting from, for example, -5, -4, 0, and then 2 and 3, etc. And double data type, it can be any number with fractional part. What a Boolean type? Boolean type is very simple. There are only 2 possible values for the Boolean type, either true or false. So true and false over here, they are literal values. So literal means whatever you write is going to be defined right away, just true or false. Okay? When we talk about the collection of Boolean values, it's very simple, only 2 possibilities. But when you talk about how to manipulate them, it gets complicated. That's something we'll see. Okay, let's see some simple cases. How can we evaluate Boolean values? So all the relational expressions have the Boolean type. What do I mean? Remember we talked about relational. If you want to compare what's the relationship between 2 numbers. The first one, let's see have the mathematical concept, Java, and some example. Let's say this. One example is here. In math, you will say less than or equal to. In Java, you will say less than and equal. And then you can put any number between any 2 numbers. In this case, you're saying that R, which is a variable, is less than or equal to 5. Let's say for the moment, let's say R happens to store the value 5. In this case, R is less than or equal to 5 should be evaluated to true, because 5 is less than or equal to 5. So that's true. On the other hand, if you say 5 larger than or equal to 5, that's also true, right? Etc. Depending on what the value is at the moment. Okay. Let's see another example here. What about this? We also got less than and larger than. In this case, you can see that R storing 5 is less than 5. That should be false. Because 5 less than 5 is false. You can either true or false. And this is something might be new to you. I'm not sure if I mentioned before. How do you say something is not equal to something? That's how you do it. So you can say something is not equal to, use the exclamation mark over here. You can say, for example, R is not equal to 5. But R is storing 5. 5 not equal to 5, false. Okay? Is it clear? Okay? Simple ones. Now, let me just mention something as a warm-up. Let's say, so here we got different expressions over here. So for example, we got x larger than, the leftmost one. X is less than or equal to y. So there is another way to write it, which is completely equivalence. When we say x is less than or equal to y, it's equivalent to saying it is not the case that x is larger than y. Agree? Like that. Okay? We can say that whenever you say, we'll talk about exclamation mark, which means logical negation in just a moment. But whenever you say it is not the case that x is larger than y. Okay? Let me just show you how you can see this, these are equivalents. Okay, let's see that. Let me just add a new slide over here just to illustrate this particular point. Okay, let's see this. I'm claiming that when I say x is less than or equal to y, this is completely equivalent to, it is not the case that x is larger than y. But how do we see that? Let's just take one example over here. Okay? What about, let's say x happens to be, let's say 3, and then y happens to be 5. For this particular example, let's see why it works. Okay? So now x can be plugging by 3. Y can be plugging by 5. 3 less than or equal to 5, true. Okay, true over here. So now, what about this expression over here? This expression here is a little bit more complicated in the sense that we have to evaluate x larger than y first before we can take the so-called logical negation. But let's try together. We'll talk about logical negation more formally in just a moment. What about this part here? Again, x is replaced by 3, y is replaced by 5. 3 larger than 5, we got false. Okay, and then we say not the case, false, negated. Remember, we only got two possibilities. You can either go from true to false or false to true. Okay, so now not false, you get true. You can see now we got a green result over here, true over here and true over here. So they are really the same. Okay, that's just one illustration. Hopefully you got it. Okay, you can see others as well. When I say x larger than y, it is equivalent to, it is not the case, x is less than or equal to y. So they are really the same. Okay, you can see others as well. Any questions until now? Are we okay? Okay. Okay, let's just review very briefly about the if statements. I only introduced very informally last time. Let's see a little bit more formally. Let's think about what kind of syntax you can write for the if statements. And then we try to understand a little bit what it really means very intuitively. And then we'll see many examples today to really get a solid understanding. That's the plan. Okay? Now, basically, this is the simplest if statement you can write, which means you have only a single if, which is a keyword, and then you start with parentheses, opening parentheses, and then some Boolean expression. Boolean expression means any expression that's going to evaluate to either true or false. For example, if x less than or equal to y, and then I'll do something. I'm sure you have used things like this for your lab number 1 and currently lab number 2 as well. Okay, so this is the simplest one you can write. A single if, so this is mandatory. So if you want to write an if statement, if it's a minimum, you should really write. Okay, and then over here, you can have as so-called, so what's really under, okay, let me just explain that very quickly. Let's explain some terminology quickly. Okay, let's say this. So now, if I say if, and I put something over here, I'll just say, for example, x less than y. If that's the case, I will do something. For example, I would say I declare some integer I is assigned to 3, followed by, let's say, maybe print line over here. I would say I multiplied by 2. Just one example over here. Okay, let's try to understand some terminology. First of all, this is a single if statement. Okay, over here. The whole thing over here, starting from if, ending by the closing brackets over here, is called if statements, a single one. Okay, and then over here, the Boolean condition over here is so-called a branching condition. Okay, branching condition. And the brackets over here you saw, opening and closing. You should really try to always put some pair of brackets. We'll see some example where you might miss the brackets, but you got to be careful. We'll get there when we talk about the common errors. Okay, and then what's really inside over here? Let's see. Let me use a different color here. What about here? Let's say over here you can see this, which means declare this integer variable and then print something. This whole thing over here is so-called the body of the branch. Okay, so this is the body of the branch, or just the body. Okay, some terminology: branching condition, if statement, and also body. Okay, so I'm going to refer, kind of use this terminology throughout the lecture. Okay. Okay, let's go back, and then let's see. So that's the simplest one you can have. Now, the next question is, how can I have slightly more complicated if statements? There are two possible things you can do. Either you can try to have an else if. Okay, when I say else if over here, I just put another Boolean condition here, and then as many statements inside the body of this particular branch as I like, and then this is just this kind of the second smallest. Okay, so now I'm going to say, just syntax-wise, let me just note what we have learned so far, okay, for if statements. So we talk about if statement. Syntax-wise, simplest one, case number 1. A single if, some Boolean condition here, and then curly brackets, you got something over here. That's the simplest one you can have. Okay, what about the second one? The second simplest you can have is something like this. You can say if over here, and then similar as before, and more than that, you can have else if. Just another Boolean condition over here, and then you have the body over here, and then also the closing brackets. There's a closing bracket over here. That's the second easiest. Okay? And there's another one that's the third easiest. Pretty much the same. Now, I can say number 3 over here. I can say if over here, and then the body over here. Now, I don't have any else if, which is okay. Else if is only optional. I can have a single else. So this, you can think about over here, 3 and 2. They are the second minimum you can get. Okay, but we'll talk about what they really mean. They mean something different. Okay? We'll talk about them. Okay? And now, what about if you want to expand further? If you want to expand further, that'll be the general case. The general case would be, let's say you have the first if, and then followed by else if, and as many else if as you like. And then, finally got an else. That's the longest one you can have. In general, depending on what you really need. So that's, you gotta define your if statement according to what you need. Okay? Okay. Let's see some I will see examples throughout the course. Let me go over all the examples first. If you got any particular confusion, you can let me know. Okay? Let's try. Okay, one more confusion point I want to mention here. Now, and it's really important for you to know how to count. I'll give you one example here, maybe a few. All I want to know is how many if statements do I have? Okay, let's say question 1. Oh, question 1. How many if statements do I have? Oh, can you see the screen? Sorry about that. I will just. Okay, how about that? Okay, that's better. Okay, good, thank you. So now let's say the first case over here, we got some Boolean condition over here, we got something over here, and then we have else if something over here, and also we got else if, and then we got something over here. Now, how many if statements do I have? 3, 2, 1, or 0, or 4. Let's say it's a multiple choice. Okay, how many if statements do I have? The answer should be 1. Okay, let's see why. Remember we said that at least, you should have at least the single if, followed by as many else if as you like. So this else if still belongs to the original if, and this else if also belongs to that. So we are talking about a single if statements. Okay, but what it really means, I'll get there. Let's understand the syntax first. Let me give you something very similar. What about this? What about, let's say, question 2. Again, tell me how many if statements we have. Okay, like that. Let's say I start with if over here. Okay, I've been running out of space, just like that. Now, how many if statements do I have? 1, 2, 3, 4? 3, okay. Let's see why 3, okay. Yeah, it's a big class, so I cannot really just wait for answer, right? Okay, let's try. First of all, the first one over here, let's try to see why 3. That's the first one. It can only be expanded by either else if or else. But we don't have that anymore. We just start with a new if. So it's got to be a second one. Okay? And then the second one is basically if, and then the else if over here is basically belong to the same if statement over there. And then followed by, once we're done, so this else if can only be expanded with just else or else if, right? But now we can see we just got the final one, if. So we got 3. The reason that we want to count to see how many if statements we need to have is because each if statement here is independently executed, so you should really execute one after another. So we'll see in some examples there, depending on exactly how many if statements you have to execute a code for how many times. Okay? We'll get there. But now you want to get an intuition about how you can count the number of if statements. It's really important. Okay, let's go back. Okay, good. And now let's go to, so this is kind of the flow chart I showed you before. Basically, you will see much better resolution when you download the slides. I'll try to maybe upload the a complete PDF page for you so you can study for that. Basically, a single if statement here, if, let's try to understand the, I'll give you some idea over here, rather than the flow chart. Oh, where's my iPad? Good, over here. Okay, let's see another example here. Let's try to see what it means to execute a if statements. Okay, now how do we execute it? So, executing an if statements. You can also find out the textual description on the slides, but let's describe that over here in the most intuitive way. Okay, let's say this. If I say, if something over here, I will do something. I'm going to use some color pen to show you, but in just a moment. I would say, else if, and then, like that, and then let's say, else if, okay, let's say that. So now, let me just use some color here to show you. Let's say this is the first branching condition here, and this part is the body of the first branch, okay? And then let's say this is the second branching condition, and this is the body for the second branching condition over here, okay? And now let's have another color here. What about pink? So that's the third branching condition, and that's the body of the third branch, okay? So now, what does it really mean when we want to execute this particular single if statement? What does that mean? This is how it works as follows. We're going to execute the code from top to bottom, okay? So now what we'll do is, now, first of all, we're going to evaluate this condition over here first, and then to see if that's true or false. If it happens to be true, you will execute this body of code, and then you ignore the rest of the branches. Okay, it's really important. We'll see example, but now you really should, okay, let's see this. If this, let's say case number 1, I'm going to use different color as well. Once this is executed, the rest, how about remaining branches? How about later branches? Later branches are ignored. You'll just go to the end of the code. Okay? That's case number 1. Let's see a second case. Let me use a different color. What about blue? Okay? Let's say the second case. Now I try to evaluate this first branching condition here. Let's say it happens to be false. That means I simply don't go into the green part to execute the body, right? What I will do is I will go to the second branching condition over here, the orange one, and evaluate that. Let's say it happens to be true. If it is true, that means I'm going to execute this body over here, and then once this orange part is done, I'm going to ignore the remaining branches. Okay, the similar logic. Basically, you're going to keep trying to evaluate the branching conditions as soon as you hit the very first one that you evaluate to be true. You're going to execute that branch, ignore the rest. Okay, so far so good? Okay, hopefully that's clear. Now, question for you. Let's say in this particular case, what if let me try the third case for you. Let me use, what about green over here? Let's say I try to evaluate this, but it's false. And then I skip the green part. And then I evaluate the orange one, it's also false. So I skip the orange part for the branching, for the body. And then I evaluate the pink part, it's also false, let's say. In that case, do I have to execute anything for this particular if statement? No, no. So now you might be wondering, but sometimes it might be useful to say, we're going to do some action anyhow, even if all the branches are false. That's when the else branch can be useful. Okay, let's do that very quickly. Okay, okay. Now just as a very quick recap, the way you're going to evaluate a single if statement over here is that you're going to evaluate the branching condition from top to bottom. As soon as you hit the very first branching condition that you evaluate to true, execute the body and then ignore the rest. But now we're talking about a special case. Let's say all the branching conditions are false. What should we do? Okay, so now that's why you should always have a good practice like this. Let me show you. Let's have another page. Let's see, add a new page below. Okay, let's have another case. Let's say we got if something over here, and then we do something here, else if, and then else if, and then finally we have something called else. Okay, I'll give you a concrete example in just a moment. Let's get some intuition first. Again, let's have different maybe color to show. Branch number 1, branch number 2, and then branch number 3, and then let's say we got no this. Okay, what about final one? You can see that how many branches do we have? 1, 2, 3, 4. I got 4 possible actions that might be taken, right? Especially we have the else branch. Else branch has a special name for that. Okay, it's called a default branch, which means it's going to guarantee default branch, which means when all the previous branching condition evaluated to false, when all the previous branching conditions evaluate to false, this branch is executed. Okay, let's try to see one example here. Let's say, imagine that we are trying to evaluate some our code at the runtime. Let's say over here, let me use, how about here, okay? Let's say, first of all, we try to evaluate this condition over here. It happens to be false. So we'll skip the green part of the body. And then we evaluate the second branch, which is orange. It also evaluate to, let's say, also false. In that case, we skip the orange part of the body, okay? And then we evaluate the next branch, which is darker orange over here. And then over here, let's say, also evaluate to false. So we also skip the third branch. So now we have no more else if to go. In that case, we'll simply just go to this branch no matter what. So that's the default action. Okay? But we're going to see examples to see how these things will put into concrete values. Okay. Okay, let's go on. Okay, let me see. So these are simply just the exactly what I just described in words. You can read over the slides. Okay. Okay, let's now have a look at some example over here. Let's try. First of all, let's say we have integer I is now going to store 5 after this line. And now let's consider the following if statements like that. Okay? I want to switch to iPad because I want to annotate a bit. Okay, how about this? Okay? That's exactly the same. Okay? Now, what would be the output from this block of code? Any idea? I is less than 10, that's what I heard. Okay, let's try it, shall we? So now, let's see this. First of all, we know that I is now assigned to 5, which means when we evaluate the first branching condition over here, what's that? It's basically evaluating 5 less than 0, which is false. That means we bypass the first body, right? So we don't execute this. And then we go to the second branch over here. So we got 5 less than 10, which is true over here. And then that means we're going to execute this particular branch. So that means I is less than 10. That's what we're going to output. But now the next question is, what after this? After we execute this particular line, are we going to evaluate I is equal to 10 again? No, we don't. We simply, you can think about, we just bypass the remaining part of the if statements. Once the very first branch has been executed, it's going to be ignored. Okay, that's really important. Okay, okay, that's the first example. Okay, that's basically what you get. Let's see something that's a little bit quite similar. Okay, actually, I can just use this one again. Let's have a look at this. What's going to happen here? Are we going to print out anything? Why don't we try? Now, let's say I is assigned to 12. Now, when we evaluate this, 12 less than 0, false. We're going to bypass this over here. And then, what about this? We got 12 less than 10, also false. We also bypass that branching body. And then we go to the third else if over here. Then that means we got 12 is equal to 10, also false. So far, no branch will be executed. However, we are reaching the end of the if statements. So nothing is going to be executed, just blank. Okay? That's what happened. Guys, are you following? Okay. So basically, so for now, we are seeing some very simple Boolean expression over here. We're going to see how we can build something that's more complicated using logical operators. That's something we'll get into today. Okay? Okay, let's see another one. Let's just go back to the slides and then to see what happened. Okay, just nothing. Okay, as I said, nothing will be printed. So you should really get quite used to this kind of program tracing problems. If I give you a fragment of code, you should tell me what the output should be. So you should really know how to trace it. Okay. Okay, another one. So now, what about this one? Okay. Okay, let me just go back to iPad and let's try that again. How about this one here? Let's try again. Let's try to be like a machine, okay? So now, over here, we got the first branching condition to be evaluated. 12 less than 0, we know that is false. Easy. Okay, we go to the second branching condition over here. We have 12 less than 10, which is also false. Okay, we also bypass the second body over there. What about here? You can see 12 is equal to 10 is also false. So far, it's very similar to what we saw before in the previous example, right? Because we got the first 3 branching conditions all evaluating to false. But now, this program here is a little bit different in the sense that over here you can see that we have an else branch. So what does that mean? That means if all the previous branching conditions evaluate to false, we're going to execute this no matter what. That's why it's called a default branch. Okay? So in that case, we know that all the 3 are false, so we're just going to execute this. Okay? It's going to be just what you saw on the slides. Okay? Let's see more. Okay, so now over here, let's just go back to our original problem there. Remember what we had before? We simply prompt the user for some radius value, which we don't constrain what they can be. It can be positive or it can be negative. Now we want to see how we can improve our program a little bit so that when the value that the user enter happens to be non-positive, in that case, we're going to give them some error. Okay? You might do the same thing for your app. Okay? Let's try to see what we can do. Okay? Let's just go over the code, and then I will show you 2 variants for the code. Okay? But you can definitely try that on your computer. Okay? Up to now, the same as before. We just declare some scanner for the input from the keyboard. And then we're going to have the radius read from the user and then declare the pi. So far, just identical to what we had before. But now we want to somehow define something like this. Let me just show you the idea because we got 2 versions of the program. You can choose whichever one you prefer. Okay, let me show you here. This is also in general something you can try to apply at page below. Okay, now I'm going to show you basically two possibilities. Because we know that we're going to basically, let's think a little bit more intuitively. We're going to read some input from the user. Okay, some input. Okay, so now we got 2 possibilities. Either we can say that if the input is valid. In the case where it is valid, we're going to do some computation. Otherwise simply means if input is valid, evaluate to false. That means it is not valid, right? In that case, we're going to say, let's say print some error. Okay, that's the first flavor you can have. Okay, that means we first try to evaluate something so-called valid condition. Of course, this is not valid Java syntax yet, but I'll show you how you can do it. Let's understand that conceptually first. What about second flavor? The second flavor looks like this. We kind of flip it around to say we check for the error condition first. If it has error, display the error. Otherwise, do something. Okay, let's try that. We can say if the input is invalid. Okay, it's a different condition, but logically speaking, this condition will be very relevant to this condition at the left. I'll show you in just a moment. Okay, if it is invalid, you will say print some error. Otherwise, you can do something. Do some computation. Okay, so now how do we call that? We call this condition over here some error condition. Yeah, you can either first check for a valid condition, or you can first check for invalid condition or error condition, either way. So these 2 are completely equivalent, okay? But now let's see how we can apply this pattern over here to our example there. Let's see how we can do that. Okay, let's see. Now, let's see the first flavor. So now let's think about for our particular example, what does it really mean for the input to be valid? Since we are reading radius from the user, right, over here, radius, what does it mean for the radius to be valid? It should be larger than or equal to 0, for example, right? It should not be negative. That's why we can say, well, sorry, let's do error condition first. I forgot, okay, the same. Let's do the second case. So now we say that what does it really mean for the radius to be invalid when it is negative? So we say that if the radius is negative, then that means we should print out some error or display some error on your mobile screen. Otherwise, we can go ahead and calculate the area and display it. So that's the second case you saw in the iPad notes, right? The second case over there. That's the second case over here. To say if the input is invalid, in this case the radius is negative, then we will try to print some error. Otherwise, do some computation. Okay, that's the first pattern. Okay, let's see something that's completely equivalent. Okay, so now tell me something. If I want to somehow flip the condition a little bit, we should really take something so-called logical negation. For those of you who are taking 1019 or 1090, maybe that's something you have exposed to already. But if you haven't, I'm going to show you. So now, if I want, so radius less than 0 means it is invalid. What does it mean for that to be valid? That should be exactly the opposite, which means it is not the case that radius is less than 0. Okay? So what do I mean? Let me write it down for you. Okay? This is kind of the math you should do in your mind. I know that radius less than 0 is the invalid condition. So now the question is, what do I mean by valid condition? It would be, it is not the case that radius is less than 0. And remember the rewriting we talked about in the previous slides. That would be equivalent to radius larger than or equal to 0. Okay, that's kind of the math you should really get used to. Okay, so that's the valid condition. Let's try. If you go back to the code over here, the second version. Now we can say that if radius is larger than or equal to 0, so that means under this circumstance, we're going to do some computation because the input is valid. Otherwise, that means the radius is not valid. It's actually less than 0, negative. So that means we'll print off some error over here in the else branch. Okay? So this is only just one example. What I really want you to pick up is really about these two patterns over here, 1 and 2. Okay? Which pattern you want to use is completely up to you. Some people might want to check for error condition first. Go ahead. If you want to check for a valid condition first, also, that's also fine. Okay? Any questions about this example here? Okay, okay, let's go on. Okay, so we also got one if statements versus multiple if statements. So this is really about the counting I mentioned to you before. Okay, let's try. Okay, now I'm going to switch to iPad and show you. Before we see this on the slides, I would like to show you in this way. I want you to look at these two blocks of code. Let's call this one here, 1 over here, and 2 over here. First of all, do they contain the same number of if statements? Okay, first of all, first question. For number 1, how many if statements do we have? Only one. Only one if statement. Okay, what about number 2? How many if statements do we have? 2, right? We got 2 if statements. So these two blocks of code are syntactically not the same. They're not the same. However, the next question is, if you try to execute them at a runtime, are they going to behave the same? That's the question. Okay, now let's try. I want you to pay attention to the two Boolean conditions over here. First of all, I larger than or equal to 3, and the second condition is I less than or equal to 8. Okay? And then I'm going to do the same annotation over here. I larger than or equal to 3, the same. And then over here, I less than or equal to 8. Okay? Now, let's agree that we got exactly 2 Boolean conditions here to be checked. However, they are being checked in different contexts. In the first example there, we got only a single if statement. In the second example there, we got 2 if statements. That's the difference. Okay. Now, can you tell me that for number 1, what are we going to print out? How many lines, first of all? 1 line or 2 lines for the first one? 1, right? Why don't we try to see? Okay, now over here, you can see that over here, I is 5. So we can replace I by 5 over here. 5 larger than or equal to 3 is true. So that means we're going to execute this particular line over here, and then we're going to ignore the remaining branches for the same if statements, right? And we're done. So only 1 line to be output. Now, what about the second one? How many lines are we going to print out, though? Let's try. Now, you can see that we got 2 independents. So you can see this if statement over here versus the second one over here. They are completely independent. Okay, let's see how. Now, I is assigned to 5. Okay, now 5 larger than or equal to 3 is going to be true. And then we execute the body of this branch over here, and then we are done with the very first if statements. Now we'll go to the second one. The second one there, we evaluate 5 less than or equal to 8. Is that true or false? That's true. However, in the previous case over here, we did not bother to evaluate that because the earlier branch was already true, so we don't do it. However, in this case over here, they are separate if statements. So now, when we evaluate this, it will be true over here, so that means we'll execute this as well. So you will see that, and that will make a conclusion for you. You should really learn a general pattern from there. Okay, for the first one, we only output only the earliest one that's satisfied. And then for the second one, we actually output for each individual if statements. So now, let's try to see why it is the case, right? Why do these 2 blocks of code behave differently, even though we are using the same 2 conditions over here, right? I larger than or equal to 3, and also I less than or equal to 8. Why? The main reason is as follows. If you try to look at the 2 conditions over here, let's say this is number line over here, right? You got minus infinity, also you got plus infinity. That's the number line over there. Oh, guess you should remind me about it. Right? So why? So we got minus infinity, we got plus infinity. Okay? So now how do we see the conditions over here? So now you can see that we basically got 3 and 8 as the 2 cutoff points. 3 here, and we got 8 over here. So what does the green condition mean? The green one is basically like this. The green one is I is larger than or equal to 3, like that. Anything that's larger than or equal to that. And what about the orange one? The orange one is anything that's less than or equal to 8. So somehow they overlap. And then the values I give to you over here, which is 5 over here, and 5 is exactly one of the values that actually sits on the area where both conditions can be satisfied. So now, depending on whether it's 1 or 2 you're using, in the case of 1, it doesn't matter if both conditions can be satisfied. It doesn't matter because only the earlier satisfying condition will be executed. In the second case over here, because both conditions are satisfied, so we'll execute that twice. Okay, that's why. But you should really study this example more carefully. Okay, I'm just trying to use one example to show you. So in some cases, when you say if, else if versus if and if, they do make a difference sometimes. You should know when exactly. Use this example to give you some idea. Okay, let's see another one. Okay, I'll just use iPad again. Let's see this one over here. Now, okay, that should look very familiar over here, right? Very familiar. Okay, now let's try the following. The conditions are a little bit different. Let's try to see. Okay, now the 2 conditions we have is I less than or equal to 3, I less than or equal to 3, versus over here I larger than or equal to 8, I larger than or equal to 8. Right? Now tell me something. If I try to execute this block of code where we have only a single if statements, how many lines are we going to print out first? And then if we try to execute this block of code, how many lines are we going to print out? I think print out the same thing or? Same. Good. Thank you. Let's try. Now, I is assigned to 2. Okay? And then you can see 2 less than or equal to 3 is true. That means we'll only print out this line over here. And then it doesn't matter if the orange one is true or not. Doesn't matter. We simply don't check it. Okay? Now, for the second one over here, so that's that's 1 and that's 2. For the second one, again, 2 less than or equal to 3 is true. So that means we're going to execute this. But we will still evaluate the second condition, which is independent if statements. In that case, 2 larger than or equal to A, we got false. That means we don't actually execute that. So now what I want to draw your attention is, when you have the same conditions over here, green and orange, in the previous case also green and orange, sometimes they might behave the same. Sometimes they might behave differently, depending on what the conditions are. Okay? Now, in this case, why do they behave differently? Sorry, why do they behave the same? Why? So now let's try to see the same argument over here quickly. This, again, is the number line, right? We got minus infinity. We also got plus infinity over here. Okay? Now, the 2 cutoff lines we got was 3 and 8 over here. Let's now try to see how the 2 condition will show in the, on the number line. Before, we simply say the 2 condition overlap. But now, do the 2 condition overlap though? Why don't we try? Now, what about for the green one? The green one is I is less than or equal to 3. And the orange one over there is that larger than or equal to 8. Okay? So that means these 2 conditions cannot be satisfied at the same time. So now, when we give the value over here, which is 2, and that's exactly over here, the 2 over here, it will only be satisfied by one branch, but not both. Okay? That's why for this particular one over here, it doesn't really matter in the second case if you also check the second condition. Okay? So these 2 examples are tricky, but they are selected over here to show you to really understand what really if condition versus if and if they really mean. Okay? Any question about these 2 examples here? Are we okay? Okay. Hopefully you're learning something beyond 1012, right? I hope. Okay, let's see more. Okay, this one I already explained on the iPad, so you can just read them through. And again, the key is the 2 conditions over here, they cannot be satisfied simultaneously. That's really the key. You should really try to review the iPad notes over there. Okay? Okay, so now there will be a few more examples over here. I will skip them just for now because I really want to get into the logical operators, and then I will also talk about classes and objects. Otherwise, we'll be behind. Okay, I will come back to these examples. They're rather easy, but you can feel free to study ahead for these. I want to go to logical expression right away. So for these 3 examples, I'll come back to them maybe next week. Okay, but they are simple. They are not difficult. Okay, and also I'll come back to primitive versus compound next week too. What I want to do is logical operators, because there's something that you will find useful for your labs. Okay. Okay, what's really logical operators? Okay, so they are basically just for you to create compound. Compound, you can think of compound means complicated, something that's beyond simplicity. You can create compound Boolean expressions. Okay, so now how can you say some analogy? Similar to arithmetic operator, for example, you got plus, you got minus, you got multiply, you got modulo. So those operators are for you to build up some complicated or compound arithmetic expressions. Now for logical, you can also do that. But you got to learn about different logical operators. But we're going to see how you can do that. Remember we said before, the simplest Boolean conditions you can get. Let me just go back there and then show you something there. Okay. Okay, I'll come back to this example a little bit later. Okay, so now let's try something here. Okay, when we talk about Boolean expression, okay, what's the simplest we can get? Simply just Boolean literals. Okay, so now you can either get either true or false. So these are the simplest one. Okay, it's true or false. And to get it slightly more complicated, you can say, for example, x is less than or equal to y, or you can say y is larger than z. So these are slightly more complicated, but all the expression evaluate to either true or false. Okay. Now, the third level, which we're going to show you, you can try to use the so-called logical operator to make it more complicated. So over here it's called Boolean Literals. And then over here, this is called relational expressions. And relational expressions will give you either true or false as well. But now what we're going to see is, we're going to learn about 3 different logical operators to see how we can build, how we can combine relational expressions together to make something that, that's going to be more powerful. Okay? I'll show you some useful application in just a moment. Okay, the third category we're going to see is how we can use logical operators. So logical operations. Okay, that's something we'll see right away. Okay, let's go back there and see how we can do that. Okay, for example, we can use the ampersand. I've seen some of you using them already. However, I've seen some cases where your lab number 1 doesn't quite work because you use the wrong logical operator. You got to be careful, because if you actually use the wrong logical operator, for example, we got the difference between ampersand versus vertical bar. They have different meanings in terms of logic, which I will introduce to you. Okay, I don't assume that you know this already. Okay, if you somehow use, for example, vertical bar instead of ampersand, they mean something completely different. You got to be careful which one to use. Okay, okay. So now we're going to consider 3 logical operators. Okay. So now let's try to understand them informally, and now I'll show you how you can understand their meaning mathematically. Okay, it's not too bad. First of all, this should not be too strange to you. Explanation mark. They simply, well, it stands for logical negation. Negation means flip the result from true to false or false to true. The meaning is simply not. It is not the case that it is true, so that it must be false. The second one is, we're going to have ampersand. Be careful, it must be 2 ampersand operators altogether. Okay? And this is something called logical conjunction. Conjunction means you got to combine things together. So the meaning is something and something must be true at the same time. Okay, the third one is called logical disjunction. So logical disjunction has some kind of similar meaning to logical conjunction, but they're not exactly the same. Okay, that's why we introduce you 3 different operators. I'll get to each one of them. Okay. Okay. Now, before I get into this, I'll get to the slides, but I'll rather use the iPad to introduce you, to give you some intuition. Okay. So now, let's say this. First of all, we got logical negation. Logical negation here. Okay, how do we do that? Basically, every time if you want to apply logical negation, you want to apply that to some Boolean value, either true or false. Okay, so now let me just show you something here. So the way you show the meaning for some logical operator is by using some so-called truth table. Let's see how we can do the truth table. Okay. Logical negation, first of all, is a unary operator. Remember we talked about operator before, right, in the elementary programming lecture. Unary means there's only a single operand you're going to apply. Okay, let's try. This is the simplest case. Now let's try to enumerate all the possible operands for this particular logical operator. Okay, so it's a unary one, so only a single operand. Okay, single operand means the operand must be a Boolean value. In this case, what can it be? Well, either true or false, right? Okay, this is how I'm going to do it. Let's say I'm going to use green for true, and then I'm going to use pink for false, either true or false. Okay? Let's say this is some variable which will store some Boolean result. Let me just say B over here. Okay, so B can be either true or false. Okay, now what does it really mean? When I try to build something that's slightly more complicated than B, I would say exclamation mark B. Now what does that mean? That means given what B has, I'm going to apply certain rules to change the expression value a little bit. Okay, for logical negation over here, we just negate. So what does that mean? If B happens to be true, and then I simply just do negation, that would change that to false, like that. If B happens to be false, and then I try to negate it, then I'll get true. Okay, true to false, false to true. Okay, why don't we see some very simple example in Android Studio very quickly. Okay, let's see over here, I'm gonna use, let's have a new class over here, Java class. Let's say logical operator tester. Okay, so you can have an idea. Okay, let's try this one here. Public static void main string args. Okay, let's see what we can do over here. So now, very simple. The way you define you declare Boolean variable is like this. You can say Boolean, just like that, is a keyword. And then B is, let's say initially just true. Okay, happens to be true. Okay, so this line here is valid. Now, what I want to do is I can say Boolean B2, just another Boolean variable. And the way I'm going to assign to it is to say whatever B value is, I'm going to assign the negation of that to B2. Okay? Now, after this, if I try to say system.out.println line, if I say B2, what would that be? False, right? So kind of get an idea. Okay? We'll see much more complicated manipulation for the logical operator, but the simplest one. Okay? You can feel free to try to see what the output should be. Negation is very simple. I want to get to the other two. The other two is a little bit more sophisticated. Okay, that's logical negation. Okay, if you go over it, you will see that there's a truth table I talk about: true, false, and false, true. True to false, false to true. And how can we use it? So this is just one example over here. Let's see this. Let's say you're trying to read the radius from the user, and then you have some Boolean variable here is positive, and we're going to assign this to the value for the expression radius larger than 0. Think about what's going to happen. If the user's input happens to be 3, in that case, what value will be stored into is positive? True. Why? Because radius will be 3. 3 larger than 0 will be true. So true will be stored into is positive. Okay? Now, let's try another input. If the user enters, let's say, -3, in that case, -3 larger than 0 is false. So that means is positive is false, which means it is not positive. Right? That's why you got some logical thinking over here. Now, what do I mean over here? I say that if it is not the case that it is positive, then I will try to print out some error. Otherwise, I'll do some computation. Okay? Let me write this on the iPad and show you. Okay? You want to know how to manipulate this kind of thing. Okay, let's make it something very simple. So we say that, let's say double over here, radius is, input dot next double, for example. We're going to read it from the user, but I'll show you a different value. And then we say that a Boolean variable is here, and then we say is positive. Okay? And then we'll say that it's assigned to radius is larger than 0. Okay? And then we say that the following. If it is not the case that it is positive, then what do? We do some error. Okay, I'll say error for here. Otherwise, we can do some computation. Okay, the 2 branches, right? Let's try different input value to see how it will work. Okay, let's try the first one. Let's say the input from the user happens to be, for example, 4. Okay? That means radius is going to store 4. And then radius over here would be 4. 4 larger than 0 would be true. That means it's positive is going to store true. Now, what does it really mean when we try to evaluate this logical expression over here? Because it's positive over here is true. Explanation mark, which is logical negation applied to true, is going to flip the result, which means it's going to give us false. That means this branch over here is false. So we are not going to print out the error. And then instead we're going to execute the computation. Okay? What if this is an error? Let's try. Let's try this one here. Now let's try the following. What about the user enters -2 as the input? And we know that eventually what we want to do is print out some error. How does that work? If -2 over here, that means the radius is going to store -2. And then radius here will be -2. -2 larger than 0, false. So that means over here is going to store false. Now, is positive over here is going to be just false. And then we apply the logical negation to it. Not false would be true. Not false here would be just true. That means this branch over here is going to satisfy. And then we're going to print out the error. Okay? You can see if you try these two different categories of inputs, it's going to give you the right result. Okay? Are we okay? Or you want me to slow down and do it again? Are we okay? Okay? So now there's something you want to get used to, the logical operators. Okay? Okay, so now, another two logical operators I want to talk about before I go to classes and objects. I want to talk about conjunction and disjunction. The logical negation is a unary operator. So now we're going to talk about binary operators. How do they work? Okay, let's go to the iPad again. Okay, I'm going to talk about conjunction and disjunction at the same time. Okay, first of all, conjunction and disjunction. So this is the way I understand it. Conjunction is more like and. And disjunction is more like or. Okay? So what do I mean by and? And means the overall conjunction will only be true if the left operand and the right operand are both true. If it is not the case, if either one of them is false, then the conjunction will be just false. Okay? I'll show you the truth table in just a moment. What about disjunction? Disjunction simply means or. It will be more relaxing to say the disjunction overall will be true if either left operand is true or the right operand is true. So what does it really mean when the disjunction is false? That means both operands are simply just false. Neither of them is true. Okay? Let's see the truth table. Okay? Now, let's draw the truth table here. Now, you can see conjunction, how do you do that in Java? You will do left-hand side and right-hand side. Okay? And also for disjunction, left-hand side over here, vertical bar, and right-hand side. Okay, so these two. Okay? So now, let's just say to make it for illustration, let me call this B1, and this is B2. And this is also B1, this is also B2. And B1 and B2, they're simply just Boolean variables, which means B1 can store either true or false. Similarly, B2 can also store either true or false. So now, to really construct a truth table, how many possibilities do we have to consider? 2, 3, 4, right? Hopefully you got it. Okay, so now let's try that. So this is how I would do it. Let's try that. So B1 and B2 over here. And then we got 4 possibilities there. Okay, let's try that. It's either true and true, true and false, false and true, and then false and false. Okay, these are the 4 possibilities. Okay, but we talk about what the final result for the conjunction should be in just a moment. It's very easy. Okay, I'll get there in just a moment. And then over here we say B1 conjoined with B2. Of course, B1 and B2 can also be some Boolean expression, but we'll get there. Okay, I'll show you some example. So now, what about disjunction? And the input for B1 and B2 will be the same. Let's enumerate them first. You got B1 here, you got B2 here, and then you got B1 or B2. Okay, let's try that. Okay, similarly, so now we can either have true, and also true and false, false and true, and then we have false and false. Okay, it's the same 4 inputs. So now this is how you should know it. You don't memorize it, you just understand it. Okay, think about what conjunction really means. That means we're going to say conjunction will only be true if both operands are true. How many rows do we have this case over here? Only a single row. That means B1 and B2 will only be true if both are true. What about other rows? Other rows simply means either B1 is false or B2 is false, or both are false. In that case, you will simply get something like this. False, false, and false. Okay, that's how you think of it. Now, what about logical disjunction over here? Logical disjunction means it's either B1 is the case or B2 is the case. Now, let's think about what does it really mean when the disjunction happens to be false. That means both are not the case. Okay? So now, how many rows do we have such case to say both B1 and B2 are actually false? Only one row, right? So the only row that should be false is this row over here. That's the only one. Okay? Now, what about the remaining 3 rows? It's either B1 is true, you can see over here. For example, for this particular row, you can see this row over here, only B1 is true. And then this row over here, only B2 is true. But for this row here, both are true. All of these 3 possibilities is going to make the disjunction just true. Okay? So in that case, what we got is true, true, and true. You can see the symmetry over here, right? For conjunction and disjunction. So what do you expect to know? I'm not going to question you about how the truth table should look like in the test or in the exam, but you should know if I give you some logical expression, you should know how to evaluate them. Okay, that's something we'll see. Okay? Any question about the table for conjunction and disjunction before I move on? We'll see some example. Okay? Let's see. Okay, conjunction over here, let's see some example here. You can see exactly what I just said. Okay, you can just refer to them. Okay, now let's try to see over here. Okay, over here, let's try that. We'd say we have an age, the integer for the user, which can be any number. Let's say between maybe 15 up to maybe 85, something like that. Let's say we have 2 Boolean conditions over here. We say that the first one is old enough, which is when age is larger than or equal to 45. And then we say it's not too old, which means it's age less than 65. Okay, something like that. We got 2 Boolean conditions over here, depending on what the input value age is. Now we say that if it is the case that the user is not old enough, in that case we apply some young people, for example, rate for the movie tickets or whatever, right, to them. And what about the else if part? We say that it's old enough and it's not too old. That means both conditions are the case. So what does that mean? Okay, I want to show you this because this could be relevant to your future labs. Okay, I'll write something on the iPad and I'll show you. But I want you to look at the else if condition there to get used to it. So this is the kind of stuff you want to get used to later. Okay, let me just try to, I'll put something on the iPad first and I'll swap. Okay. Okay, old enough, age larger than or equal to 45. Now also Boolean, also we got not too old, and in which case we got age now less than 65. Okay, So now let's switch the iPad over here. Okay, let's try to understand what does it really mean to put them together using logical conjunction. What does that mean? Okay, if I simply say old enough and not too old over here. Why don't we try some input values over here? Okay, and then I want you to make some conclusion at the end. What kind of mathematical equation or expression is this particular expression here equivalent to? Well, that's something we'll get into. That's why it's so relevant to your labs. Let's try. Let's try first of all, what about we simply say this? Let's say the age happens to be, for example, let's say 50. Let's try that. Okay, if that's 50. Now, 50 larger than or equal to 45 is true. 50 less than 65 is also true. And then we have true and true. So we get true. In some way, we are talking about 50 is in between 45 and 65, right? Okay. Let's see another case over here. What about, let's try another case over here. What about, let me use, what about pink over here? What about I try 70, okay? Hopefully you can see the difference, okay, 70. What about 70 here? If the age happens to be 70, so what does that mean? That means 70 larger than or equal to 45 is true. What about 70 less than 65? What is that? False. So we have true and false. We get false. So what does that mean? Somehow that means 70 is not in between 45 and 65. Okay? But let's see what this really corresponds to. When we say this over here, this is really equivalent to the following mathematical expression. That means the age is really in between 45 and 65. That's what it really means. So now, when we actually gave the first input value 50 over here, it's in between. So it's true. But for the second value over here, we gave 70. It's outside the boundary for this particular interval here, so that should be false. Okay? Now, how is this related to your lab? Let's try to talk about it. Okay? Let's try to see this. Let me just try something example, hopefully you can relate to your lab. Let's say I got some mathematical definition over here. I want to translate that into Java. I want to know which one should be the right one. Let's say this. Let's say I got 25 less than or equal to, let me just say, what about just say I, okay, to make it simple. Let's say I is an integer variable. And then less than or equal to 35. Okay? Apparently, if you simply do this, how do we do this in Java? Right? That's a question. If you simply write the following, 25 less than or equal to I, less than or equal to 35, it's not going to compile. Okay? First of all, not going to compile. To really do an interval like this, we have to use logical expressions. But now you want to know which one to use. Okay? Okay, let's try to see which one you can use. Okay? Try the following, and then we can say 25, let me give you two choices again. Let's use this. Okay, number one, I can say 25 less than or equal to I, and then also I less than or equal to 35, right? I'll give you both cases. And then we're going to decide which logical operator to use. Less than or equal to I, and then I less than or equal to 35. Let's say for case number one, we're going to use logical conjunction. And the second one, we're going to use logical disjunction. Okay? Either 1 or 2 is equivalent to this mathematical expression over here. 1 or 2. Okay? Some of you might have already realized it should be 1, but do you really know why? Okay? Let's try this. I can tell you that, first of all, of course, you don't memorize because I may not just want you to do the translation in the test. I want you to know really how this is going to behave. Why don't we try the second one, which is not the case, okay? So how do I show that this one here is really not the way to go, okay? Let me try this. Let me try a value that's outside the boundary. For example, if I try 40, if I try 40 over here, is 40 in between 25 and 35? No. So this should be false. We know that the expected result should be just false. However, if we apply this input value 40 over here into here, what's going to happen? If I is 40 and I here is 40, is it going to evaluate the true or false? Let's think about it. So 25 less than or equal to 40 is true. 40 less than or equal to 35, well, it's false. But now, according to the definition for disjunction, if either side is true, overall it's going to be true. Because we already have this side over here to be true. So overall it's going to be true. You can see that this true over here is inconsistent. It's inconsistent with what we're expecting. Okay? But now, what about the same input value over here? How do we plug in the value for conjunction? How do we do that? Why don't we try? Now, if you have 40 over here, you got 40 over here. Now, 25 less than or equal to 40. True. That one is the same as before. And also, 40 less than or equal to 35 is false. Now, but overall, is it going to evaluate to true or false? To be false. Because now, when we talk about logical conjunction, it must be the case that both operands are true. If either one is actually false, overall it's going to be false. Okay? So now in that case, overall is going to give us just false. And this false over here is really consistent with what we have before. So this is why you should really realize that this is how you can express an interval in Java. Okay? Any question about this? Okay. Are we all right? Okay. Okay, there's logical disjunction here, and again the truth table here, and then here simply just a different manipulation for the variables. I'll leave that to you. Okay. We'll talk about logical laws next time. Okay. We still have about 25 minutes. I would like to talk a little bit about classes and objects. Okay. There's something we want to get into. Okay. Okay. So now let's go to classes and objects. And by the way, the slides are already on the web. So that's something you can start studying already. Okay. So now let's simply just get to the slides for classes and objects. Yeah, the if then else statement we talk about today is definitely much harder than elementary programming. That's expected. If you think it is already confusing, you really want to get to study that, apply that into your labs. What's going to be more complicated is when we talk about iterations or loops. That's something we'll talk about perhaps after the lab test one. Okay, so that will actually make your code more powerful, because you definitely need loops to make things more powerful. Okay, okay. Let's go over some slides here, and then I would like to maybe spend 25 minutes just to go over some coding on the Android Studio. So you can actually relate that to your lab number one. Okay? Remember in the tutorial series, the model part over there, all the videos, that's something you're also expected to learn. Okay? You're expected to watch already. Okay, let's go over the first one. So far, in your tutorial series at lab number one, we have got a single Java class called person. Okay? And I call it a model. Model simply means it's the components of your software that is going to contain all the intelligent logic. So whatever you want to do, anything that's beyond conversion or input retrieval, they should belong to the model. Okay? And then there are two kinds of code that we can write in order to manipulate the model objects. Okay? That's what we learned. So one is a controller, right? The activity file. You got to define the button click method there, and then define line by line how you can manipulate the person objects. We have seen some example in lab 1 and 2, and things will get slightly more complicated, when we move on. Okay, controller is one example there. Also, we got tester. So tester is also something that as you're developing your person class or any other classes, that's something you should really try to test your method as soon as they become testable. It's the test-driven developments that we talk about in the tutorial series. Okay? Now, that's something just to remind you about what we learned. Now, in Java, actually, you may get a wrong impression that whenever we talk about model, it's always going to be a single class called model. For example, for lab number 1, you got only the person class. For lab number 2, you only got a taxpayer class. That they will be sufficient. But in Java, you actually can define as many model classes as you like, depending on what you need. For this particular course, it's only more like an introduction to Java programming. So we wouldn't go too much beyond 2 or 3 classes, maybe maximum 2 classes to show you the idea. When you get to 2030, you might get to maybe 3 or 4 classes. When you get to 3311, software design, you might get to 20 classes, 10, 15 classes. But when you graduate from the degree, when you work in industry, don't be too surprised. You got about 100 or 200 classes. It's definitely possible. Okay? But we always learn from the basic. Once you understand the basic unit for just single class and how you can relate 2 classes to each other, then expanding that to the concept about 100 classes is not too far. Okay? It's always going from 0 to 1 and 1 to 2. That's really the most difficult one, which I hope to get you through in this course. Okay? And then within each class, you can define 1 or more methods and attributes, etc. Okay? I'll go to here in just a moment, but now I want to give you some concept over here. Not too sure if I got my notes over here. That's fine. Okay. Now, for those of you who already follow, okay, let me just mention this. So if people ask you about what's the difference between classes and objects, that's your simple answer. Classes are simply for defining templates, and objects are for you to instantiate, to create instances. Okay, that's the difference between classes and objects. Classes are templates, only a single one, and objects are basically multiple instances of your classes. Okay, that's a very simple answer to that, but we'll see exactly how. Given a class, you can instantiate as many objects as you like. For example, for the person class you created for lab 1, you can create a person object called Jim. You can create a person object called Alan, Mark, Tom, and as many as you like. Okay, so now, so this is a diagram I would like to get into maybe next time. Today, I just want to get into helping you with some object orientation, developing some code right away. And then we can focus more on the ideas maybe next Monday. Okay? So now I want to go to Android Studio over here. Let's try something a little bit different. You have seen the person class for many times already. Let's try something different. What about let's try to do how we can create instances for 2-dimensional points. That's something you haven't seen a lot. Why don't we try that? Okay? And I'll go to the slide maybe next Monday. But for now, let me spend the last 20 minutes or so to do some example. Okay? Now I want you to let me go to projects over here, and then we'll create some classes. And then I will especially I want to explain to you the different kinds of methods you may have. Okay? Okay, so now first of all, I want to create a new class, Java class. Again, the convention is it must be capitalized. Let me say point. Okay, point over here. Let's now also learn about the structure for your class. Let me just use iPad here first of all. What should be the structure of your class? For those of you who are just learning Java, I would say following this pattern over here can make your beginning learning a little bit easier. For those of you who are experienced, you don't really have to, but this is what I would recommend. That's how you can think of it. Okay, now let's not just worry about public versus private. Let's not worry about them just for now, okay? Let's say I have a class over here called point. Class over here, there's a keyword in Java, and then you put the name of the class. Let's say point over here. And then opening brackets and closing brackets. Inside, you have the complete implementation for your class. Okay? Now, I would like you to think about, we can divide each class into different sections, okay? That's how you can think of it. First of all, we can have attributes, okay? Let me say the first section here is our attributes. Okay? Some people also like to talk about attributes as class variables. Okay, I'll get to there. But I would say just focus on attributes. So we got attributes, and also we got one or more constructors. From what you have seen in the tutorial and in lab number 1, you may have a single constructor for the person. But in Java, you can define as many constructors as you like, depending on what you want to initialize. Okay, we'll get there. Also, we got constructors. Okay, and then we also got another section over here. You can get one or more constructors typically. And also you got something called accessor methods. So these are the methods which can tell you something about the objects you're querying about, okay? Basically just asking questions. Okay? And then the final section is you also got mutators, mutator methods. So these are for you to do changes. Okay, so we got attributes, we got constructor, we got accessor, we got mutators. So these are the 4 sections you can expect to have for every class. Of course, sometimes people would like to mix constructor with mutator with different order. That's fine. Okay, but I would say if you want to make it simple and clear, that's kind of the order you can follow. But I'm going to show you how you can do that. Okay. So now let's think about how we can define the attributes for the point. Okay. Let's think about what happens when you think about conceptually. This is how you draw a 2-dimensional plane over here. Let's talk about the Cartesian system, right? What you learned from the math. Cartesian simply means we can characterize each point in the 2-dimensional plane using x and y coordinates, right? So for example, you have one point over here, let's say simply 2 and 3. Another one over here, maybe 2 minus 3, okay? So for us to really characterize what each point should be, we need 2 attributes. Basically, one is the 2, which is x coordinates, and the other one is 3, which is y coordinates. So that's why we need 2 values. Of course, as you get more and more experience, you should see based on what you observe on the real-life entities, you should really see what the attributes are. For this course, we almost always tell you what the attributes might be, but you really want to practice to figure out the attributes yourself. That's something you will do as a software engineer later. Okay, but I'll try to train you on that. Okay, let's go back to the Android Studio and let's try to do some coding over here. Okay, what about attributes? Okay, section number 1. Okay, attributes. We characterize each 2-dimensional point using its x and y coordinates. Okay, that's what we do. That's the comments. How do we do that? We can now actually declare variables. Now, how do we declare variables like attributes? Again, what we learned from elementary programming was type and name. Now, we're going to decide what a type is. If I simply say integer and x, would it be appropriate? Now, you're going to decide. First of all, well, let's try a different variety. You can either try maybe string x, okay, for example, or you can try double x. So these are just different alternatives you can take. But we're going to decide only one of them. You can only declare a variable only once. So now, how do we know what the value should be? Should it be double, integer, or string, or character, right? We've got many types that you can decide. Now, you should really go back to our original concept over here. When you talk about the possible x and y over here, what can be what are the possible values you want to handle? If you only handle things like 2 and 3, 2 and minus 3 without any fractional point, in that case, integer should be enough. However, if you also want to model points like maybe 2.5 and then 3.4, in that case, you need double. Okay, that's how you decide. Let's now make it as general as possible. What about double? Apparently, string is not a choice, right? Because when you talk about the x and y coordinates, they are numbers. They are not strings. Okay? Okay, let's go back there. And let's try that. What we can do is double x and double y. Okay, only two attributes. Okay, only two attributes. So now let's talk about how we can create instances for a class. Okay. What we learned from the person class was there's only a single constructor over there, but I'm going to show you different possibilities. Okay. Let me show you the following. Okay, and we're going to use an if then else. Okay, let's see the simplest one. Okay, let's say we can say point over here. So as soon as you see that a method's name has the same name as a class, that means a constructor. Okay, as I said in the tutorial. Let's do the simplest way, the simplest one that you're familiar with. I can say double x and double y. You can give any name as you like. How about this? I'll make it a little bit simple for you. Let's say new value of x and new value of y. Okay, like that. And now, how do we actually define this constructor over here? We can do the following. We can say this dot x is assigned to nx, and this dot y is assigned to ny. Okay, that's what you can do. But let's try to understand what this constructor really means. It's really important. I'll make sure I explain it properly. Okay. Okay, let's go to our iPad over here. Okay. What I will do is I'll copy that definition there and let's see what we can do. Okay. Let's say this. We have class point double x double y. And then we have points over here. Okay, let's say double over here. New x and x. I chose this name intentionally not to be clashing with the x over here, so it's easier to see. Okay, and then also double new y over here. And then we say this dot x is assigned to x, and also this dot y is assigned to y. That's all we have. Okay. That's our definition. Now, let's see how we can apply this particular class definition already. Okay? Let's see this. This is how we can use it. So now, the way we create an object to create instances, create an instance from the template over here. Okay? You can think about this as a template for points. Yes. Thank you. And x and y, right? Good. Okay, so now let's see how we can create an object of type points. Let's see. Okay, I'm going to write this single line here. This is how you can do it. Now we can say points over here. Let's say P1 is assigned to, okay? So now this is something you have done already, possibly haven't really understood so fully. Okay, let's try to understand that. It's assigned to new. Over here, we also got point over here. And then we have, let's say go back to our example here. Let's say we want to create something like this, 2 and 3. 2 and 3. Okay, what does that mean? Let's try to understand this line very carefully. Okay, again, as I said in the tutorial, let's say we try to divide this particular object creations line into 3 parts. Okay, so this is the first part. And first part over here. And this is the second part. And the assignment over here is the third part. 1, 2, and 3. Okay, now let's see how these are going to look like. The first part is maybe the most important one. Whenever you say new over here in Java, that means you're going to allocate space in the memory. Okay? as you learn, possibly from 10, 12, or other, maybe in the high school introduction to computing. So we don't really talk about computer in a, usually when you talk about computer at the lowest level, you got a sequence of bytes for the memory, right? So now, let's only try to say this, okay? I'll just say it for the first time. Let's say over here, let's say this is your computer memory. Okay? It's simply going to be a sequence of bytes, okay? Just like that. Sequence of bytes over here until the end, okay? Depending on how large it is. Okay, each segment there is a byte, okay? And also we got address for each byte, right? So now, for example, here can be, I'll just make that up. So maybe 0011, 01 is binary number, address, okay? The absolute value for the address does not really matter. I just want to show you one example, okay? So now, whenever you see the new keyword here, what does that mean? That means the Java compiler at the runtime is going to allocate some space to create these objects over here. And what would it take to really store these particular objects? It depends on what attributes you have for that particular objects. So what attributes do we have? We got X and we got Y. So these are the data that we have to store for each particular object of type point. Okay? So now, what does that mean? So now, what that means is, over here, we're going to allocate in the memory a portion over there. I'll just show you to you here. Okay, I'm going to use just a portion of the memory like this. Okay, just a portion over here. Okay, over here. And over here, the memory is going to store the objects of type points. And we know for each point, object is going to contain X and Y. Okay, it's going to be X somewhere here and Y somewhere here. Okay, other things, but mainly the attributes. So now, when we call this constructor over here, when we say points over here, currently we only got one constructor for the class. That means we're going to call this particular constructor over here. Okay, so now, what does it really mean when we call this constructor? Okay, now, be careful. Okay, so now let me just draw your attention to this. Over here, you can think about this green one over here is how we declare constructor. And this one over here, point, this is how we call the constructor. So what do you mean by call? Call simply means to use it. Okay? Let me just draw some very quick analogy back to your high school. Okay? If I have something like this, I have some add function over here back in math. If I say add x, y over here, it's going to return back to me x plus y. I can think about this part over here means the decoration. I'm declaring a function called add, which will take x and y. But how do I use it? The way I use it is by saying, for example, add 3 and 4. You can see over here, I'm trying to call this particular function over here. So now x will be substituted by 3, y will be substituted by 4, and then apply that to the definition there in the body. It's going to be 3 plus 4, which means that'll give me 7. Okay, we got exactly the same idea for calling a method in Java, just like how you call functions in math that you learned before. There should be nothing surprising here. Okay, okay, let's go back there and see how we can understand that one there. Okay, now if you look at this one here, you can see over here, we are going to call this constructor here called point with 2 and 3. Okay, that means the nx and ny is going to be replaced by 2 and 3 accordingly, right? That's how we're going to call that. Just like how we call the x and y over here, just like that. Okay. Now, what does that mean further? Let's try the following. We got 2 here, we got 3 over here. That means nx over here is going to be substituted by 2, and ny is going to be substituted by 3. Okay, 2 and 3. So far so good? Now, not only that, every occurrence of nx in the body of this particular constructor is going to be substituted by this value here, 2. Okay? That means nx over here is also going to be 2. ny here is going to be substituted by 3, 2 and 3. Okay? It's just about passing the inputs. Okay? Now, how do we, but so far we haven't done anything to the memory just yet. Now, here comes the thing. I'll talk a little bit more about this next time. But every time when you refer to an attribute in your class, implicitly there's a this over here. This simply means the current object we are talking about. Okay? So now, if you look at this object over here, we are really creating this particular object over here. So that's really this is referring to, this object here. When we say this.x, what's this.x? This guy here is this.x. This fragment over here. And what's this.y? Well, this is this.y over here. So these two fragments over here. So now, when we say this.x is assigned to 2, it's going to basically put 2 over here. When we say this.y is assigned to 3, then we're going to put 3 over here. So after executing this constructor over here, we're going to assign 2 to be here and 3 to be here. Okay? So this is how we allocate the memory in the allocate the object in the memory and also assign its attributes one by calling the constructor. Okay? That's what step number 1 would do. Okay? That's only one. Allocating the position in the memory for the objects, assign all the attribute values according to the constructor we are calling over here. Okay? Now, what about 2 over here? And the 2 over here is going to be very similar to what we learned before. Okay? When we say we declare a variable p1 over here, what does that mean? That means we're going to declare a placeholder called p1. If we simply declare p1 to be integer, then it can store integer only. If we declare that to be string, it can store string only. But now, when we declare that to be a point, what does that mean? Okay? So now let's try this. When we say the point here, that means we can only store the address of some point objects only. That's something you really want to get used to. Okay? We don't really store the entire objects over there. We store only its address. Okay? In this case, when you get to number 2 over here, I'll just say over here. So P1 is going to store the address of some point objects. That's what number 2 will do. Okay? It just declared that. Now, finally, what does that mean when we say over here is assigned to? Assigned to means we're going to store the address of this particular object, which in this case is 001101, into this particular P1. Okay? If we do that over there, it's going to be stored at 001101. Okay, that's number 3. So these are the 3 steps for this particular line. But conceptually, how we can understand this, let me just do that quickly. Conceptually, you can understand this as, okay, you can think about, let me just do the line once more, okay? Point P1 is new point. And you will see that later on the slide, I talk about how you can visualize object, which is very important. Let's say 3 and 4 over here. Okay? Now, again, this is number 1. Number 1 here, we create simply an object over here, a rectangle box, and the title of the box should be the person. Sorry, not point, person, point. The class that we're creating. And then there should be 2 columns over here, and then we got attributes x and y. Right? By calling the constructor with 3 and 4, we got 3 and 4 over here. Okay? By declaring a P1 variable here, we just got P1 over here. Okay? So that's step number 2. Okay, finally, over here, when we have this assignments over here, that means P1 is going to store the address of the objects. It's not going to store the entire object, only the address. That means conceptually you can draw like this, an arrow. P1 is going to point to these objects. So this is step number 2. So these are the 3 steps. Okay? So this is really might be the most important line to really understand for today. Okay? Because we're going to talk about classes and objects throughout the course. I'll try to repeat this a little bit by defining a different constructor next time. Okay? But gradually we will cover all the important aspects for classes and objects. But we might just be a little bit behind the labs. But you should really try to study ahead if you can. If you got questions, you can ask me. Okay? Now, let me stop the recording. There's one thing I want to say. Okay?